Hello everyone, my name is Kesari Nandan and today we are going to solve the LeetCode problem longest substring without repeating characters. Okay, so let's read the problem statement. So here it says given a string S, find the length of the longest substring without repeating characters. Okay, here if you hover over the substring, it also gives the definition of the substring and it says a substring is a contiguous non-empty sequence of characters within a string. So the substring should be contiguous. What does it means? You can see example 3 here. It has clearly said that the output of this example is 3 and I am assuming that this is the 3 character that is the output here. So it says the answer is WK. Yeah, this is the 3 character with a length of 3. So length is 3 that we already know. Notice that the answer must be a substring. Okay, so the answers that we return should be a substring. Here PWKE is a subsequence, not a substring. Okay. So you can also try to make a substring and let's say if you take first character here P and you take 3 characters from here, right? So this will have a length of 4 and all the 4 characters will be different. But this is a subsequence, not a substring. And if you hover over it again, it says contiguous. So contiguous means if you take W, right, you need to take K just after that. If there is a W again here, then you cannot skip it. In this case, like since we have taken P, so if we want to take a substring, then we have to take this W. We cannot skip this one. So that's why this is a not a substring. This is a subsequence if we consider this string. All right. I hope now you understand the problem. Now let's try to solve the problem. So let's try to solve this very naive way. Okay, so let's take a variable called result. Okay, if I can type, and the length is by default, let's say it's a 0, and let's run a loop. So let's calculate the length first. So we can say length of a string. Okay, and here we can say for I in range length, and then here we can also take a variable, let's say temp, and this is going to store the uh, length of temporary substring. Okay, and also let's take a variable called substr, and by default this is going to be an empty variable. All right, so let's run another loop for j in range, and this will go till the end, but this will start from I. Okay, and this will go till the last length. All right, so here we are storing the substring. Let's make it a set actually, and how let's say this is the cache, because we need to just return the length, so we don't need to return the string, and set is fast if you are doing the search. So what we can say, we can check if we have seen this character that we are running on. Okay, so we can say if s dot I in cache, or let's make the variable as a scene. If we have seen this character, then let's put a pass and let's write the else condition first. If we have not seen this, then what we are going to do, we are just going to uh, add the character into this scene set. So we can say scene dot add. Okay, and we can add the character here, j. This should be j also, and we don't need temp actually. Let's remove this. Okay, and if we have seen this, then what we are going to do, we are going to actually break this. So we are going to exit this loop. Okay, so we have not still since we have seen this, so we are skipping the loop, and here what we can do, we can say if length of scene is greater than the result. Okay, if it's greater than the result, then we can say result will be the length of scene. And I think that's it. We don't need to do anything else, and we can just return the result. Okay, so if we try to run this, you can see all the test cases are passing, right? If I talk about that time complexity and the space complexity of this problem, so let's put the time complexity, and this is going to be the O of, we are running one loop and inside that we are running another loop, so this is going to be the n square, and space complexity, since we are not using any extra space, here we are using the space, so let's say this is going to have the on extra space, because it may happen that the entire string doesn't have any repeating characters, so you will store every character into this one. Okay, so that is fine, but this is the very naive way. You can see the time complexity is very not good. So let's try to optimize this, and let's try to solve it with another logic, and so that we can reduce this time complexity. Okay, so I have taken the first example from the problem statement, and let's try to find out the solution. Okay, the result that is expected from this string is 3. Okay, so let's actually visualize how many substring we have who has the length 3. So we have first, we have second one, we have third one, and we have fourth one. So these are the 4 substring which is having the length 3 without any repeating character. Okay, so from the problem I can see that we need at least 2 index to calculate the length. Okay, and to do this we need the 2 index, right? So we can use the 2 pointer approach. So here also I'm just going to use the 2 pointer approach, and so for the 2 pointer I will need pointer 1 p1 and I will need pointer 2 p2, and when I start this loop, right, my both pointer will be here at index 0. So let me actually write the 0 0 here, and from here, from the start I will start calculating the result, because it may be the case that every character is a, so I need to return the 1 there. So if I calculate the result, so the result will be p2 minus p1 plus 1, because whenever you are using the index to calculate the length, right, so when you take the start index and the end index, so you need to do the plus 1, because in case of this 0, if you calculate right now 0 minus 0, and if you don't do the plus 1, then you will not get the 1 as a result, because your both the indexes are at the same position. So we have calculated the result as 1, and if I talk about the substring, then this is a, but here we need the substring without repeating the character, right, without any character being repeated. So in that case we need to store the character that we have visited. So let's create a cache, and we can store a here, and we can put the character as a key and index as a value. Now let's move to the b, and we will check if we have seen the b previously. So we have not seen, so we will update the b here in the cache, and we will calculate the result. So at b it will be 1 minus 0 plus 1, and this will be 2, and my substring is going to be ab, this one. All right, in the next iteration our p2 will move to the c, here index 2, and we will check if we have seen the c previously. So we have not seen, so we will update the c index here in the cache, and we will calculate 2 minus 0 plus 1, and this will give us 3, and now our substring is abc. So this is a valid substring. Once we move to the next pointer 3, I mean we move the p2 to index 3, we will have this substring, this entire substring. Okay, a b, let me write it correctly, a b. Okay, so this, our substring is going to be this one. Okay, now this is an invalid substring, and we will if we check this last character, right, at index a, we have seen this character previously. So whenever we find a character that we have previously seen, in that case this substring becomes invalid, and to make it valid we need to move the p1, and next position of p1 we can say, let me actually put it here. So we can say next p1 will be previous position of p1, and we can get the previous position of p1 by checking cache of, since we have found this one, right, so we can put the character here plus 1. So this is, here you can see the index was 0, so 0 plus 1 is 1. So the next position of p1 is going to be here at index 1, and now we can calculate the result. So to calculate the result we can say 3 minus 1 plus 1, this will give us 3, and substring will be b c a. And since we have recalculated the we have again seen the position of a, right, I mean we have again seen this character a, so we need to update the index of this a. So index of this a was 0 previously, so we will put 3 here. Okay, we will repeat the same again. So let's try to go to the next character, that is b, and this will be 4. So our substring is going to be in this case this one, and b, this is an invalid substring, and b we have already seen here in the cache. So what we will do, whenever we find a repeating character, we calculate the next position of p1, and if I try to calculate the next position of p1, so the previous position of b was 1 and then 1, so this will be 2. So next position of p1 is going to here. Okay, now we can calculate the result. So result will be 4 minus 2 plus 1, and this is going to be 3, and substring that is giving this result is CAB. And once we have calculated the result, we need to update the index of b. So index of b was 1, now it will become 4. So we have an index as a 4. And next, let's move to the next character c here. And in case of c, it was 4, so yeah, this index will be 5. So c we have already seen here in the cache. So whenever we find in the cache, we calculate the next position of the p1. So this will be previous position of c plus 1, so this will be 3. So we will move the p1 to here 3, and since we have moved, now we need to calculate the length. So this will be 5 minus 3 plus 1, and this will give us 3, and the output will be a b c. So this is the substring, and we need to update the current index of the c. So current index of the c is 5. Let's move this to next position, that is 6, and if we check, we have already seen the b. So what we will do, we will calculate the next position of p1, and how can we calculate that? We can get the previous position of b, that is 4 plus 1, so this is 5. So next position of p1, here you can see it's not moving one step, it's actually taking the previous position of the b. So this will move here, so p1 will go to the 5, and now we will calculate the substring, a value substring, that will be 6 minus 5 plus 1, so this will give us 2, and these two substring will be c and b. Now we will move one step ahead, p2 will go to the 7, and again we can okay, so I forgot to update the position of the b. So position of the b here will be 6. Now if I move to the b, right, I will check if I have seen b previously. So I have seen the b previously, so I will create the next position of the b, of the p1. So it will be 6 plus 1, that is 7. So this will move to here only, and now if I calculate the substring, this will be 7 minus 7 plus 1, and this will be 1, and the substring is going to be b. Alright, so these are the substring, and if I take maximum of every result, right, so the output will be 3. Okay, so this is how we can calculate the result. Let's try to handle one more substring where I think there will be a problem. So let's say the string is going to be let me use different color. Let's say the string is a b b a. Okay, and output will be 2 for this case. And if we try to find out substring, this is a valid substring, this is a valid substring. So there are two substring that is valid, and we can put the cache here, and we have a p1 and we have a p2. So p1 is here, p2 is here. If I calculate the result, will be 0 minus 0 plus 1, this will be 1, and our substring will be a, and our cache will store a 0. And if I move the p2 to the next position, so this is 0 1 2 3, so this is 1. So we have not seen the b, so we will put the b into the cache, and now this will be 1 minus 0 plus 1, and that will be 2, and our substring will be ab. Okay, again I will move to the b, and this p2 will go to b, so p2 will be here at index 2. Now I have already seen the b, so what I need to do, I need to calculate the previous position, I need to calculate the next position of the p1. Okay, so p1 next, we can say this will be previous position of the b, and that was 1 plus 1, so this will be 2. So this will move to here. Okay, and we can calculate the result. So result will be 2 minus 2 plus 1. Okay, so this will be 1, and the substring will be b. Okay, and we will update the current position of the b, and that is going to be 0 1 2, so this is going to be 2. Now if I go to the a, right, what will happen? Have we seen the a previously? Yes, we have seen the a previously. So what we are going to do, we are going to calculate the previous position of a, next position of the p1. Okay, so the next position, if I check for p1, then this is going to be previous position of a, that is 0 and plus 1, so this is going to be 1. So here the next position of p1 will be calculated at this one, but this is not a valid position. So whenever we create a next position of the p1, right, we need to make sure that this is not less than the what the p1 previously had. So in that case we will ignore. So this is less than this one, right? Previously it was at 2, so p1 was at 2, and p1 next is 1. So p1 was 2 and p1 next is at 1. So p1 is greater than p1 next. So we will not move the p1 anywhere. Okay, so in that case p1 will be here only, and p2 will move to this one, a. So p2 is at a, so we will calculate the length. So this will be 3 minus 1 plus 1. No, so it's here, so 3 minus 2 plus 1, and this will be 2, and our substring will be ba of length 2. Okay, and we will update the length of a, that is 3. So this is one base condition where you have such string. So you need to make sure that whenever you get the position of the p1, right, that should not be lesser than what we previously had. So this should always be greater than what we previously had. Okay, so I think this makes sense. So let's try to actually write the code for it, and let's try to run if we can find the expected output in LeetCode. So let's remove the previously written code, and we need the result. Apart from that, we need 2 pointers. So let's say left, and this is 0, and we also need the right pointer, this is also 0, and we need the cache where we are going to store the characters. Okay, So let's run a loop. So we can say for C in S, or we can, let's say, enumerate S, and here we can get the right pointer. So we can remove this. Okay, and we have these things. Now we need to check if we have already seen this character. So we can say if C in cache, that means if we have already seen. And there was one more condition, that we need to make sure that the next pointer of the left is not less than the current. So we can check that by getting the current position of the character and making sure that this is greater than or equal to the current left. Okay, so this is fine. Now we have considered the other case also, and now let's, if these two cases satisfies, we can set the position of the left pointer. So for that we can say cache current position of the character, and we can do the +1. Okay, and once all this is done, we can calculate the result by saying the max of previously what we had, and then we can do the right minus left and +1. Okay, and now we need to also update the index of the character that we are seeing right now. So for that we can say case of C, this will be the current index, that is right. Okay, once all this done, we can just return the result. I think this will be the final solution. Okay, okay, let's say see the time complexity. So you can see we are running a loop, only one loop. So this is not going to be the n square, this is going to be the n. And space complexity, so we are using the cache, right? And if the, let's say in case of ABC, BB, in this case obviously you will have only 3 characters in the cache, and you will keep updating the indexes. But maybe there is a string given like ABC, D, E, F, G, H, I, J, K, there is no repeating character. So in that case you will store everything in the cache. So in worst case we can say the space complexity is going to be the ON. Okay, and let's run the code and see if it works. Okay, all the test cases are passed, so let's try to submit this. Okay, so this works perfectly fine. So thank you so much for watching this video. If you're new to the channel, please click on the subscribe button, and thank you so much for watching, and I will see you in the next one.